Welcome to the DIY Honda Garage channel. The DTC P0108 refers to a high voltage condition in the manifold absolute pressure MAP sensor circuit. This diagnostic trouble code indicates that the voltage level from the MAP sensor is exceeding the specified threshold, which is usually set at 4.49 volts. The MAP sensor is an essential component in the engine management system, responsible for providing the engine control unit, ECU, with data about the engine's load. By measuring the intake manifold pressure, the MAP sensor allows the ECU to optimize air-fuel mixture, timing, and overall engine performance. In the Honda Civic models from 2016 to 2021, the MAP sensor is typically located on the intake manifold, which makes it accessible for inspection and testing. Understanding this error code and its implications is crucial for proper vehicle diagnostics and ensuring engine efficiency. The DTC P0108 specifically points to a malfunction in the manifold absolute pressure, or MAP, sensor circuit. The MAP sensor plays a critical role in accurately measuring the pressure inside the intake manifold. By doing so, it provides vital information to the engine control unit, ECU, which helps in adjusting fuel injection and timing for optimal engine performance. In the Honda Civic models from 2016 to 2021, this sensor is generally found directly attached to the intake manifold. Its electrical connectors must maintain a secure connection to prevent erroneous readings that can lead to performance issues. The MAP sensor's location makes it relatively easy to access for diagnostics and repair, which is important for ensuring that it can relay accurate information to the vehicle's onboard system. Several potential causes may lead to the occurrence of DTC P0108 in Honda Civic vehicles. First and foremost, a faulty MAP sensor can malfunction due to internal defects, resulting in high voltage readings. Another common issue is poor connections, which can occur due to corrosion, looseness, or damage to the connectors at the MAP sensor or the powertrain control module, PCM. Additionally, wiring issues such as breaks or shorts in the wire can lead to incorrect readings. Each of these problems can disrupt the communication between the MAP sensor and the ECU, which in turn influences engine performance. Identifying the root cause is critical for effective troubleshooting and repair of this issue. The symptoms associated with DTC P0108 can significantly affect the performance of the Honda Civic. One of the most noticeable signs is the activation of the check engine light on the dashboard, alerting drivers that there's an issue that requires attention. Poor engine performance is another common symptom, which can manifest as reduced power, unexpected stalling, or difficulties during acceleration. Additionally, rough idling may be encountered as the engine struggles to maintain a steady RPM due to faulty readings from the MAP sensor. These symptoms indicate that the engine control unit may not be optimizing fuel and air mixture effectively, which can lead to long-term engine problems if not addressed promptly. The first step in troubleshooting DTC P0108 involves verifying the problem by turning the vehicle's ignition to the on position without starting the engine. Using the Honda Diagnostic System, HDS, check the data list for real-time values from the MAP sensor. It is crucial to analyze whether these values meet the described threshold of more than 4.49 volts. If the values exceed this voltage, the issue can be confirmed. However, if the condition does not match the threshold, this indicates an intermittent failure, suggesting that some malfunction might occur under specific circumstances. In this case, thoroughly inspect the connections between the MAP sensor and the PCM for any looseness or damage. This preliminary check ensures the system is functioning correctly before further diagnostics are performed. Once the initial checks are completed, proceed to the second troubleshooting step. Start by turning the vehicle's ignition to the off position. Then disconnect the map sensor 3P connector from its mount. To test the functionality of the sensor further, utilize a jumper wire to connect terminals A, map sensor pin 1, and B, map sensor pin 2, in the map sensor's 3P connector. After making these connections, turn the vehicle back to the on mode again. Recheck the HDS beta to ensure that the map sensor voltage readings exceed the 4.49 volts threshold. If the readings are consistent and above this threshold, the next step in the testing procedure should be initiated. Otherwise, the map sensor is likely defective, necessitating replacement. Step 3 continues focusing on further diagnosis of the map sensor circuit. Begin by turning the vehicle's ignition to the off position and removing the jumper wire used in the previous step. Then, turn the vehicle back to the on mode without reconnecting the map sensor. At this juncture, measure the voltage between the specified test points. Test point 1, map sensor connector pin 1, and test point 2, map sensor connector pin 3. It's essential to review whether the voltage measured is approximately 5.0 volts. If the result indicates the voltage is within the expected range, this suggests a functional SG1 wire. If not, further examination of potential wiring issues will be required, leading to the next critical step. As we move to the fourth troubleshooting step, it's essential to take preparatory measures before checking for any wiring issues. Start by turning the vehicle to the off mode. Next, jump the SCS, System Check Service, line with the HDS and allow the system to stabilize for more than a minute. After this procedure, disconnect the PCM connector E, ADP, to enable access to the necessary test points. Proceed to check for continuity between the two designated test points, the map sensor 3P connector pin 1 and the PCM connector E, pin 71. Establishing whether there is continuity is essential. If continuity exists, the SG1 wire is deemed operational. If continuity is lacking, repairs are necessary on the SG1 wire, connecting the map sensor to the PCM. Concluding the troubleshooting steps is the fifth step, focusing on the PB line integrity. Initially, ensure the vehicle's ignition is in the off position once again. Following this, repeat the process of jumping the SCS line with the HDS and wait over a minute for stabilization. Disconnect the PCM connector E, ADP, once more for access to the test points. Similar to the previous step, measure the continuity, but this time between the map sensor 3P connector pin 2 and the PCM connector E pin 56. Confirming continuity indicates that the PB wire is functioning correctly. In cases where continuity is absent, then focused efforts are needed to repair any breaks in the PB wire, working between the map sensor and the PCM. After completing the repair procedures associated with DTC P0108, it's essential to verify that the solution implemented was effective. First, recheck the functional status of the map sensor to ensure that it operates within the specified parameters. Following this, clear the existing diagnostic trouble code using the Honda Diagnostic System, HDS. It's important to then take the vehicle for a test drive under varied conditions to assess its performance closely. Keep an eye on the engine responsiveness and the dashboard indicator lights. This step serves as a final confirmation that the problem has been rectified and that the vehicle operates optimally thereafter. To prevent the occurrence of DTC P0108 and similar issues, engaging in regular preventive maintenance is crucial. One effective measure is to frequently inspect the wiring associated with the map sensor for any signs of wear, fraying, or disconnection. Doing so can preemptively catch problems before they lead to engine performance issues. Regular checks of the map sensor's function can also assist in identifying any potential inaccuracies in readings that may affect engine operation. Additionally, ensure that all electrical connections are secure and free from corrosion. By implementing these maintenance practices, vehicle reliability can be significantly enhanced, reducing the likelihood of unexpected faults arising in the future. In summary, DTC P0108 points to a critical issue surrounding the map sensor circuit, which can markedly affect engine performance in Honda Civic models from 2016 to 2021. By following a structured troubleshooting approach that systematically verifies the components involved, technicians can effectively diagnose and remediate the problem. It's essential to understand the implications of this DTC to avoid prolonged engine inefficiency and potential damage. After repairs, implementing comprehensive preventive maintenance will go a long way in safeguarding against similar failures in the future. Through these practices, vehicle owners can ensure optimal performance and longevity from their Honda Civics. Please like and subscribe to the channel. See you next time.